This video is on the vapor phase method for refining metals. To purify a metal by this method, there are two essential criteria. One is that the metal should be, it should be possible to convert the metal into a volatile compound, that is into a compound which can be easily vaporized. Now, in this method, only the metal should form a volatile compound, while the impurities should be unaffected. The second criteria is that the intermediate compound, the volatile intermediate compound should be unstable. That is, it should decompose on heating at practically attainable temperatures to give the pure metal. The vapor phase refining is made use of in two techniques that we shall see in the next slides. This one is the Mond's process, which is used for purification of the metal nickel. Impure nickel is treated with carbon monoxide at temperatures of 330 to 350 degree Kelvin, which means 37 to 77 degrees Celsius, when the volatile compound nickel carbonyl is formed. This volatile compound, that is the gaseous nickel carbonyl that is formed, when heated to a high temperature, that is a temperature of 450 to 470 degree Kelvin, as you can see in the slide, this will decompose to give pure nickel at carbon monoxide. The carbon monoxide that is formed this way can be used again. The second method that is mentioned is the Van Arkel debour process, or simply the Van Arkel process. This can be used to purify metals like titanium, zirconium, hafnium, silicon, etc. The metal will be obtained in an ultra pure state, and hence this method is often used in the semiconductor industry. What we do in the process is conversion of the impure metal into a volatile compound and decomposition of the volatile compound, like we have done in the Mond's process. So here, the process involves conversion in the volatile compound that is often the iodide. That is, the impure metal will be heated with iodine. As you can see in this scheme, the impure metal is heated with iodine to give the metal iodide. This metal iodide is volatile. As you can see, it's mentioned vapors here. Then the metal iodide is heated, let's see, on a tungsten filament that is electrically heated to about 1800 Kelvin. When the vapors decompose, or the metal iodide decomposes to give the pure metal and iodine, which, like in the case of carbon monoxide, can be recycled or can be used again. Now, as an example, titanium, the solid titanium, which is in the impure state, that is associated with impurities, is treated with iodine at a temperature of 523 Kelvin. When titanium iodide is formed, this G indicates gas. That means the compound is volatile and it is in the gaseous form. Now, this titanium iodide is heated to a more higher temperature. See, if the formation took place at 523 Kelvin, the decomposition is when the compound is heated to a higher temperature of 1700 Kelvin, when titanium iodide decomposes to give pure titanium and iodine, and iodine can be further used.